Hello, I'm going to discuss my solution to the LeetCode problem sort list. It's today's problem in the October LeetCoding challenge. I am Channa Bankapur from Go Master Technologies. So it's essentially sorting a linked list of integer values in ascending order. And we are expected to sort in big of n log n time and a big of one extra memory. So we know merge sort and heap sort takes big of n log n time in the worst case, right? Quick sort actually takes big of n squared in the worst case. And merge sort actually takes big of n extra space for an array input. For a linked list, let's see whether it doesn't need that. Let's see, and also in for merge sort in an array, we can actually find, or we can divide the array into two parts in constant time, because we have random access to the middle element. But in a linked list, we don't have that, so that's a problem. But still, let's go ahead with this method and see what happens. Right. So the idea is we're going to have a linked list here, and then we need to split into the middle here. So that way we're going to have two linked lists, and then we got to sort both of them recursively and then merge two sorted lists, right? So the good thing about merging two sorted lists is here actually in an array setup, we need that extra memory in merging stage. But here merging two sorted linked list is actually easier. We have another problem in LeetCode, which is merging two sorted lists. I have done this one with big O of one extra space, which we just have to move these nodes around, and we should be able to merge in linear time with constant space. So now this is the good news. We don't need that extra space, but we have that extra problem of finding the middle, right? Which is not constant time operation. Let's see my code. How does it look like? So this is what I'm trying to do. So the base cases are very simple. If there are no nodes, or if there's only one node, we don't have to sort it. I'm going to return, right? Otherwise, I'm going to find the mid of the linked list, which is uh, which is what is happening here in this whole block of code. It takes linear time to find that. I'm just using slow pointer, first pointer pattern to find the mid of that, mid of the list. So once I find the mid of the list, head 2 is going to be pointing to the first node of the second half, and slow pointer is pointing to the tail of that. So that's why that slow dot next I'm going to setting it to a null to basically separate these two lists. So now I have two lists. One is pointed by head, another one is pointed by head 2. Both of them are of roughly half the size, right? So then I'm going to recursively sort both of them, and then merging these two lists is a method we already know, right? So that's the method here. And merging two lists is very straightforward with the same idea. If one of the lists is null, I'm going to just return null. Otherwise, I'll find the first node of the resulting list first, and then onwards things are simple. Actually, I can generalize here, but this is a little more efficient. So then I go on till at least one of the lists is exhausted, and then when one of the lists is exhausted, whichever the list we have left with, you just have to append it to the resulting list. So that's why we don't need any extra space anywhere, and also it works pretty fast, right? So let's see how whether it works for me. Yeah, it works for the sample test case, and let me submit that. It has accepted, right? See, okay, the time wise also this is pretty fast. And if you want to, let's analyze the algorithm quickly for its time complexity. So if you see, this is the method which has like input size of n. Let's see how much time it takes. We have this code which takes big of n time, and we have these two sorted these two recursive calls. Both of them take so if this takes t of n time overall, both of these takes t of n by 2 and t of n by 2, so that's essentially twice of t of n by 2. And then merging list is also big of n time, and we don't actually consume any space other than the recursive stack space, right? So the overall time complexity according to this is going to be T of n is going to be 2 times of T of n by 2 and plus linear time, right? So there are actually two methods which take linear time. One is finding the mid, and another one is merging two lists. So this is where actually, even though finding the list is expensive here, it take linear time. That is basically kind of merged within this this merging list in terms of time complexity. That's why look at this recurrence. This is just like the same old recurrence we have seen for merge sort, merge sort of two um, merge sort of on an array. So this is going to take big O of n log n time, right? So we got big O of n log n time, and space wise, it is kind of big O one extra space, but other than that, we actually take stack space here because this is recursive. This is going to need big O of log n extra space only for the stack, right? The stack for function calls, right? We can actually make it iterative also, and then make it actually big O of one. But I'm leaving it at this stage. Big O of log n extra space is actually kind of nothing, right? It's not too much. All right. So I hope this solution looks good to you. If you have implemented the iterative version of this one and then made it a proper big O of one extra space, please share it with us. Or if you have any other approaches, any questions, or any comments on this method, please let me know. All right. So otherwise, happy coding and thanks for watching.